Okay, finally. Sorry, it took 20 minutes later than I wanted to, but we're finally live on Monday, May 11th for our applied math class. Sorry about the delay again. Something that YouTube doesn't like apparently at 1 o'clock every afternoon when I try and log on. Okay, so we're in the middle of the quadratic functions. Last week we spent a lot of time exploring what a quadratic function is. And there are two ways to recognize a quadratic function. Either you have a picture, and you can see that the picture of a quadratic function is a parabola, right? A U-shaped. It can either be pointing down or pointing up. So if you're given a picture of a graph, you can clearly identify if it's quadratic or not. The other way to identify a quadratic equation is if you're given an equation. All right, so we can see down in example 2, we're going to be given an equation, not a picture. And this, I know it's a quadratic because the equation itself has a variable. Usually we see x, but this time it's a t. There's a t squared and a t, right? So as long as there's a variable squared with exponent 2, we know that that graph will be the graph of a parabola, and that itself is a quadratic function. I'm going to start the applications. We didn't spend as long exploring quadratic functions as we did linear because all the stuff we learned at linear can be applied and transferred over to quadratics, right? The quadratic was just learning a new shape to look for and a new equation to look for that squared or the exponent 2. But as for finding x and y intercepts, it was all the same. Let's take a look at example 1. I'm going to do the first 3 examples, and then I'm going to give you a bit of time to work. So grab your calculator, your simulator, get your simulator going, and make sure that your calculator is cleared out of all the old data from last week or from when you were doing homework. I don't think we'll need our calculator for example 1 because it gives us the picture already. A ball is kicked into the air. The graph below shows the height of the ball versus time. So those are the two variables, right? Height and time. And the application equation should tell you height and time, right? Height versus time. Those are the two things that go on the two labels that go on our graph. How many seconds is the ball in the air? All right, well, the ball was kicked into the air here. This is time 0, right? This is the quadrant 1 graph because everything has to be positive. So at time 0, the ball was kicked into the air. It hit a maximum, right? It went as high as it could go, and then it started falling down again and hit the ground. So in total, the ball was in the air for 3 seconds. What is the maximum height attained? Okay, well, height is on the y-axis. I think I'm going to need some kind of a straight edge, right? Or a ruler. Sometimes it's hard to read, right? So I'm just going to take and it looks like it's at 4.5, right? Right here. So 4.5 meters, 4.5 meters. How long does it take the ball to reach its maximum height? Okay, well, here's the maximum, right? This is the maximum height. How long did it take? Well, that's a time question. So 1.5 seconds. This is a quite easy question to answer because they gave us the picture. If they didn't give us the picture, we would have to use our graphing calculator. They would either give us the equation or give some info, and we would have to put the data in our graphing calculator and read the words off the graphing calculator. What is the minimum height of the ball? Well, the minimum height is when it hits the ground, right? So I guess 0 meters. The word minimum means lowest, maximum, highest. So there you go, that's it. Just remember that this point is called the vertex, right? And the y-coordinate of the vertex is always, so let's just for a little practice, the vertex would be what, 1.5, comma, 4.5. Because this is a downward parabola, it has a maximum value. And remember, this is always the maximum value. Maximum height. In this case, it's a height. All right, let's try the next example, example 2. A quadratic application with the equation given. So this time, they don't give us a picture, but they give us the equation. You are playing golf on the moon. You hit a ball with your golf club. The height of the ball can be modeled by this equation. So it seems like it's going to be a similar question to this, right? A ball is hit, goes up in the air and comes down. Sketch the graph, show the vertex and intercepts. All right, so in order to get everything on the graph, I would enter this into my calculator. I have to do a few adjustments. In the calculator, it would be y1, right? But y equals negative 0.8x squared plus 40x. Because my calculator just uses x's and y's. So I know that. This is also a quadrant 1 graph. I don't have to worry about the other quadrants, I don't think. So there's a lot I can do already. This is my quadrant 1 graph. This replaces the y, right? But they're telling me to use h, so I use h, and this will be t. So those are my new variables, but now I have to label. This again is height in meters. And this is time in seconds. Okay, so I'm ready to go. I'm ready to set up. What are the important points I need? Well, if I just kind of quickly look back up through to example 1 again. I need the x-intercepts if there are any, the y-intercept if there is one, and then the vertex, right? So let's enter our graph in. Okay, and I'm just going to enter the equation in. Negative 0.8x squared plus 40x. Press graph. So I see something here, right? I think. I can do a zoom 8. I think I'm also going to just, I don't know, I see the graph super close to the y-axis. So I think I'm going to, I don't know, let's try a zoom 0 and see what we get, right? Remember we did that yesterday? Or Friday, I guess? All right, so that helps me out a little bit. At least I can see quadrant 1. I need to see way more out here though on the x-axis, right? This is where I can adjust my calculator. You can put zeros in for x-min and y-min because it's just a quadrant 1 graph, right? So they start at zeros, but it looked like I need way more over here to see over here. So I don't know, I'm going to put 50 in and just see. I can always go back and change windows, right? Oops. So I think I need a little more, and I need a little more up here too. All right. So let's change this to, I'm just going to make it a little bigger. Let's make it 60. And let's try 350. Oops, still a little more, right? I need quite a bit more here. I'm going to try 500. Windows are easy to play around with. All right, that's not bad, right? So I'll just record the windows that I used. And remember, you don't have to have the exact same windows as I do, as long as you can see your intercepts if there are any, and if for quadratic you want to see the vertex. Okay, I'll just record the windows. I used 0 and 60, 0 and 500. If you did this by yourself and used slightly different ones, but you can still see everything, awesome, that's great. It looks like the y-intercept is over here, right? Like 0, but let's see. Second trace value, put a 0 in for x. And sure enough, it's 0, right? So that's one of my x-intercepts too. If I put y2 is 0, and now I'm going to do my second trace number 5 for my x-intercepts. Well, we already found this x-intercept. because if x is 0, y is 0, that's not only a y-intercept, but that's an x-intercept. But we can just, I'll show you, I'll prove it to you. So sure enough, oh, they're just giving me this one, 50. Ooh, let's try this one. I'm going to go all the way over to the left. They gave me 0 and 50, right? Oh, they're not giving me that second one. Okay, for some reason, I don't know why. So I know though that if it's 0, 0, it's got to be an x-intercept as well. So let's just try. I'm just going to put a 50 in here. I'm not sure why it's not letting me get that one, but get a 50 there, right? Now, halfway between should be my vertex, but let's just figure out what the vertex is. If it's a downward parabola, this will be a maximum. Press number 4. So I have to move to the left of the vertex, right? The turning point. Okay, as long as you're anywhere to the left, press enter. Now move to the right. Press enter. Take a guess. So it's at 25,500. So halfway between the intercepts, and that makes sense, right? So halfway between the intercepts is the vertex. And then, I don't know, I'll just put like a 50 here maybe. Or sorry, a 500. And then I'm just going to do this. Notice for this quadratic, I'm not putting arrowheads on the end because just like the previous example, this is a real life application. I don't have negative values. That's why this is a quadrant 1 graph. Once the golf ball hits the surface of the moon, or the ball in example 1 hit the ground, it doesn't go deep into the ground anymore. Now, I hope this makes sense. I already knew, before I even picked my calculator up, as soon as I found my x-intercepts, I knew my vertex was going to have an x value of 25 because the vertex is always halfway between the x-intercepts. It has to be. So because I had x-intercepts of 0 and 50, I knew that halfway between was 25. So I knew my x value. I just didn't know what the maximum value would be, and I needed my calculator for that. All right, so that's it. I've graphed my graph, sketched the graph, show the vertex and the intercepts. What is the maximum height of the ball? Well, this is always my maximum value. So it'll be maximum height of 500 meters. How many seconds is the ball in the air? Well, 50. Okay, it reached the ground here. So as long as you remember how to find your intercepts, the procedure is the exact same way, but just remember for quadratics, quite often you have 2 x-intercepts. All right, last example we're going to do today, then I'm going to give you some play around time with your own calculator or your simulator, whatever you're using. I'm going to finish up with example 3 because it's another equation. Quadratic or example 4 is slightly different type of example, so I'm going to save that for tomorrow. Right, example 3, equation given. Okay, so sure enough, here it is. So I know that I'm going to key this into my calculator as y equals negative 0.15x squared plus 3x. This is the arc that water makes when it's shooting out of like a fountain, right, or the splash pads. So the water itself, you can see, makes a parabolic arc. X represents the horizontal distance, V represents the vertical distance that the water makes. So the water shoots, if you can kind of just look here, the water shoots up for sure, right? It shoots up and then comes down, but it also is shooting sideways, right? It's shooting to the right and then it comes down further to the right. We don't have to do a graph this time. What is the maximum height? Okay, so same thing. So it's very similar to the golf ball going up, right? I'm going to clean my calculator out. Whoops. Clear. So when I enter my calculator in, nothing's entered in. So I get negative 0.15x squared plus 3x. And let's see what this graph's like. Well, not bad, right? At least we have a starting point. I think I need way more over on the right. So let's see what a 50 does. And way more up here, let's see a 30. I'm just going to leave my negative 10s this time. Okay, well, I probably didn't need that much, but so any kind of window settings though are fine, right? They're not asking me to graph it. If they asked me to graph it, I would just graph a quadrant 1. All right, what's the maximum height? Well, that would be my vertex, right? So second trace 4. I'm just going to move a little closer to the vertex. So I move to the left and I lock it in. And I move to the right and I lock it in. And then I take a guess. My vertex is 10, 15. Okay, so, I mean, it's not asking me for a picture, but I could draw one anyway, right? Just picture's worth 1,000 words, right? And I don't have to be fussy with this because they didn't even ask me for one. This was X, this was V. So it looks like this. Oops. So here's my vertex, 10, 15. What that means is that this value over here is 15. And it means that this is 10. So this and this, I think, because this looks like it looks like it's intersecting right at the corner, the 0, 0, but let's see. The maximum height would be 15 feet. How far from the opening can the water reach? Well, that would be this measurement, right? So let's see what that would be an x-intercept. So second trace number 5. Okay, so they're saying that occurs at 20, right? That's 0, 20. And then this is obviously if we want to prove that. And that was 0, 0. See? So that shows you the symmetry again. I knew that if this number was 20 or 10, then this has to be 20, right? 0, because 10 is halfway between 0 and 20. How far from the opening? 20 feet. Okay? So that's it. I'm going to stop today. I'm going to make it really short. And then, because I'm just going to chunk this out. So you can get to work on number 1 to 3. Number 1 is given a picture, so you don't have to do much except look at the diagram and respond. And then number 2 and 3 are given equations, just like we did answer the questions. So the tricky part might be just setting your windows so you can see everything, right? And we will do some more examples tomorrow. And we're nearing the end of our graphing. So if you've been struggling a little with the graphing, this is our last unit with graphing. And then we're going to be starting measurement. And you don't need a special calculator for that. You can just use your regular one. So that should be helpful to you. Right? So remember, you can either pop in on live chat anytime I'm streaming, or you can email me, please, with questions. So I will see you tomorrow.